All right, so let's talk 11.2. In 11.1 and 12.3, we talked about hypothesis tests on two proportions. 11.1 was about the independent case, and 12.3 was about the dependent case. In 11.2 and 11.3, we're going to talk about hypothesis tests on two means. We'll start off with the dependent case in 11.2, and then 11.3 will be the independent case. So for the dependent case, since the samples are dependent, each individual from sample 1 has a matched pair in sample 2. So to perform inference on the means of the two samples, we subtract each value in sample 1 from its matched pair, each value from sample 2 from its matched pair in sample 1, and then we perform a hypothesis test on the difference. Okay, so for example, a researcher measured the time in seconds required to catch falling meter stick for 5 randomly selected students' dominant and non-dominant hand. She wants to know if the reaction time in an individual's dominant hand is less than the reaction time of the individual's non-dominant hand. A coin flip is used to determine which hand will be measured first. The table below represents the data that were obtained. So, so she only did this with 5 students. She has a really small sample size, okay? But we'll go with it, right? So she did this with 5 students and measured their, so if they were right-handed, she measured, their right hand and then their left hand's reaction time. The difference in this case would be negative 0.002, right? And here it would be 0.008 and so forth. Oh, what would this be? 14 plus 8, so 22. So negative 0.022, and then 0.005, and then negative 0.017, I think. Okay, so what we end up doing is we just run a hypothesis test on this bottom row right here. On the difference of the two rows. So what we're going to test for is to see if the mean is 0 or if the mean is different from 0. If the mean is 0, then that means there's no difference, right? There's no observable difference on average between the dominant and non-dominant hands. So so that's what we're going to do. So really, this section doesn't introduce anything all that new. We're just going to be running a single hypothesis test. But the single hypothesis test that we run is going to be on the difference between each matched pair. Consequently, we do use some different notation, and there's even a different stat crunch procedure to run the test. So, so we'll talk about how to do those things. So notationally, D bar is going to represent the sample mean of the differences of the matched pairs. S sub D is going to represent the sample standard deviation of the differences of the matched pairs. Mu sub D represents the population mean difference. Mu sub X represents the population mean of the first group. And mu sub Y represents the population mean of the second group. So with that notation in mind, here are some things that will be useful for us when we go to run this test in StatCrunch. If our null hypothesis is that mu sub X equals mu sub Y, then the equivalent statement would be that mu sub D equals 0, kind of as we discussed earlier in this set of notes. If mu sub X does not equal mu sub Y, then mu sub D does not equal 0. If mu sub X is less than mu sub Y, then the differences are negative, and if mu sub X is greater than mu sub Y, then the differences are positive. So in the reaction time example here, if we call the dominant hand measurements group X and the non-dominant measurements group Y, we're trying to see if mu sub X equals mu sub Y, or in other words, that would mean, so we want to see if mu sub X equals mu sub Y. So in terms of mu sub D, we would say mu sub D equals 0. But then it says the researcher wants to know if the reaction time in the dominant hand is less than the reaction time in the non-dominant hand. So she wants to know if mu sub x is less than mu sub y. That would mean that mu sub d would be less than 0. Okay, so this is how we're probably going to state the null and alternative hypotheses when we write it down on our paper. But this is how StatCrunch is going to state the null and alternative hypotheses. And in reality, you're only running a hypothesis test on a single mean in these problems. Okay, so same steps as usual. Here's the test statistic. Okay, again, it's sort of a z-score, right? And then these are the corresponding p-values. Same interpretation with the p-value as usual, right? The p-value is the probability that we would get the sample statistics that we observed if, in fact, the population, or if, in fact, the null hypothesis were true. Okay? If that p-value is really small, then it casts doubt on our assumption, and so we reject our assumption, right? We reject the null hypothesis. As usual, there are conditions that you'd have to check in order to run this test. I'm not going to make a huge deal out of this, but you know, you'd have to make sure that the sample data are dependent, right, and come in matched pairs. And then you'd have to make sure that the sample sizes are at least 30, or the problem could say that the underlying distribution is known to be normally distributed, in which case you can go ahead and run the test even if the sample size is not large enough, right? Okay, in StatCrunch, we're going to go to stat, t-stats, just like before, but then we're going to go to paired, because our data in this case is going to come from matched pairs, right? They come in matched pairs, so we go stat, t-stats, because we're testing mean, and then paired, because the sample data come in matched pairs. This is how we would do it in StatCrunch if we were given the raw data. 99% of the time, that's what you're given. But you will have at least one homework problem that I can think of where you're not given the raw data. In that case, it's important for you to understand what I said a second ago, that what we're doing here is we're running a single hypothesis test. We're running a hypothesis test on one mean. So to do that, remember that you go to stat, t-stats, one sample, and then with summary. Okay, so if you're given the raw data, go to stat, t-stats paired. If you're not given the raw data, go to stat, t-stats, one sample with summary. The values that you enter in, once you do that, they're going to prompt you for the mean, standard deviation. The values you should enter in are d bar and s sub d. Okay, the sample mean for the differences and the standard deviation for the differences. We may go over an example like that together in these notes. I honestly can't remember, but let's take a look at a couple examples anyway. So this first one says a dietitian wishes to see if a person's cholesterol level will decrease if the diet is supplemented by a certain mineral. 7 subjects were pre-tested and then took the mineral supplement for a 6-week period. Test the dietitian's claim at the 0.05 level of significance. Perform a 95, I don't care about the confidence interval. Okay, but these are the results of the study. Okay. So I'm going to call the before group, group, maybe I'll call it group 1 and the after group, group 2. It says the dietitian wants to know if the cholesterol level will decrease if they take the supplement. So she wants to know if this average is less than this average, right? So she wants to know if mu2 is less than mu1, right? Mu2 less than mu1, or in other words, mu1 greater than mu2. Oh, I'm sorry, that's not your null hypothesis. That's your alternative, isn't it? That's your alternative. And so your null hypothesis would be mu1 equals mu2. So in StatCrunch, this is going to look like mu sub d equals 0, or mu sub d is greater than 0. That's how it's going to look in StatCrunch. So let's go ahead and go to StatCrunch. We're going to go to stat, tstats, paired. And then we need to enter the raw data. So let's go to StatCrunch and enter the data in. Well, maybe I should label this too. So this is the before group. And we have the after group. It's important that you get these in the right order because they're matched pairs, and so they're supposed to match up. .228 and 201. Okay. So now we're going to go to stat, tstats, paired. Sample 1, I called that column the before column, and then sample 2, I called that column the after column. And then we want to test mu d equals 0 against mu d greater than 0. So we hit compute and we get the p-value, right? So the p-value is 0.0641. By the way, let me just edit this real quick, because you can click on this little box here that says save differences. And what that's going to do is it's going to find the difference between this column and this column, and then it's going to make a new column with the differences. So this is 210 minus 190, 235 minus 170, 208 minus 210, and so forth. It's not necessary to have those, but if you ever have a homework problem that asks you to calculate all the differences, probably a quicker way to do it is to just go ahead and enter it into StatCrunch, run the test, and click that little box that says save differences, and then you have all of these stored in a column without you having to like individually punch in each one into your calculator. But anyway, there we go. There's p-value 0.0641. So let's write that down. So what that means is that there's a 6% chance that we would have gotten these results if the null hypothesis were true. That's kind of a low probability, but it's not low enough because our cutoff value is 0.05. So, so we're not going to reject the null hypothesis here. And then we'd write a conclusion detailing what that means for the alternative hypothesis. Well, if we're not rejecting the null, then that means there's not enough evidence to support the alternative. So at the 0.05 level of significance, there's not sufficient evidence to claim that cholesterol level decreases after taking this supplement. Okay, and that's that one. Okay, so let's take a look at another one. It's pretty similar idea. Give the video a pause and see if you can work this one out on your own. It says, sports fans often complain that referees show preferential treatment to the home team. Below are the number of free throws attempted by the home team and the away team in 13 randomly selected games. Using StatCrunch at the 0.05 level of significance, test the claim that the home team shoots more free throws than the away team. Okay, so I'm going to call the home team group 1 and the away team group 2. We want to know if the home team shoots more free throws than the away team. If they do, then that gives us some evidence to suggest that referees are giving preferential treatment to the home team because they're calling fouls on the away team more often. And that's why the home team is shooting more free throws, right? But I'll let you pause the video, see if you can write down the null and alternative hypotheses, see if you can get the p-value, okay? So go ahead and give it a pause, see if you can run this test. Okay, here's my solution. So the null hypothesis is that the referees don't give any kind of preferential treatment to the home team. The number of free throws shot by the home team is the same as that shot by the away team. The alternative is that the home team shoots more free throws than the away team, right? So mu1 is greater than mu2. To run the test, it's stat t-stats paired. Okay, you enter the data. Okay, and I'm going to double check, make sure that I got all the data in correctly and that it's all matching up the way it should. Okay, it looks good. Okay, stat, t-stats paired. I'm comparing home and away. I'm going to save the differences. It's not necessary, but it might be interesting to look at. And I want to run a right-tailed test. Okay, there we go. Pretty small p-value. Small enough to cast doubt on the null hypothesis, right? In other words, there's only about a 2% chance that we would have observed this happening if the null hypothesis were true. So if we assume that home and away teams shoot the same amount of free throws, then we would have only had a 2% chance of collecting this data. And yet, we collected that data, right? So it makes us suspect that probably the null hypothesis isn't true after all, so we reject it, okay? Our cutoff value was 0.05, and we're definitely smaller than that. So we're going to say, since the p-value is less than alpha, we reject the null. So at the 0.05 level of significance, well, since since we're rejecting the null hypothesis, that means there's evidence to support the alternative. So there's evidence that the home team shoots more free throws than the away team. Okay, so the evidence suggests that the home team shoots more free throws than the away team. That's what we're able to gather from the data. Now, it's interesting to think about that in terms of the original question, right? Sports fans often complain that referees show preferential treatment to the home team. You could say, yeah, this definitely shows that that's true because the refs are calling fouls on the away team a lot more often than they're calling fouls on the home team. However, it could just be that the refs are being perfectly fair, but that for some reason away teams are more aggressive than home teams, right? So you actually still really can't answer that first question. You do kind of have some evidence to support that claim, but you can't say definitively that referees show preferential treatment. Somehow you'd have to set up an experiment a little differently where you trick some of the referees into thinking that one of the teams is the home team and the other is the away team. And then you trick others of the referees to think the opposite, and then ask them their opinion about each call that's made or something like that. But anyway, so that's that example. I just have one more example to give you in this section. And yeah, sure enough, this is an example where we're not given the raw data. So I just wanted to give you an example where we're not given the raw data so that you know how to handle that when you come across that problem in the homework, okay? Because there's going to be a problem kind of like this in the homework. So it says, to determine which hotel is generally cheaper to stay at, a researcher randomly selected 10 cities in the US and chose a Hampton Inn hotel and a La Quinta Inn hotel in each city. She then compared the cost of the hotels in each city. The mean difference in cost was $10 with a standard deviation of $3.61. Test the claim that Hampton Inn hotels are priced differently than La Quinta hotels at the 0.05 level of significance. Okay, so maybe we can call the Hampton Inn hotels group 1 and the La Quinta Inn hotels group 2. The null hypothesis is that the mean price for these hotels is the same, right? mu1 equals mu2. For the alternative, we want to see if they're priced differently. So we're not trying to claim that mu1 is less than mu2 or that mu1 is greater than mu2. We just want to know if mu1 and mu2 are different. So to test this claim, we're going to go to stat. Now, since we don't have the raw data, we're going to run this like a single mean hypothesis test. So it's stat t stats one sample with summary. And then what summary do we give it? Well, we're told that the mean difference in cost was $10. So the mean difference is $10. And then we're told that the standard deviation difference in cost is $3.61. So the standard deviation of the differences is $3.61. We also need a sample size. It says the researcher randomly selected 10 cities and chose a Hampton Inn and a La Quinta Inn for each city. So that means there are 10 differences, right? There are 10 differences, so n equals 10. Let's run the test. So I'm going to go to stat, t-stats, one sample with summary. So sample mean is 10, sample standard deviation is 361, Sample size is 10. We want to test, we want a two-tailed test. So actually that's already set up the way we want it. Ooh, and look at that p-value. That's a tiny, tiny p-value. So let's write that down. Okay. So that p-value is so small that there aren't enough digits in StatCrunch to store it. They're just telling us it's some number less than 0.0001. So that means it's very, very unlikely that we would get these results if the null hypothesis were true. That casts doubt on the null hypothesis then, so we reject it, right? So since 0.0001 is less than 0.05, we reject. We reject the null. What does that mean for the alternative? Well, if we're rejecting the null, that means there's evidence to support the alternative. So there's evidence to support the claim that the two hotel chains are priced differently. Okay, and that's that one. Okay, so there's your homework assignment. We'll see you next time.